Find the center and the radius of the following circles, and then graph the circles, labeling each with at least 4 ordered pairs. To begin with, let's recall that the standard form of the equation of a circle is x minus h quantity squared plus y minus k quantity squared is equal to r squared. And when our circle's equation is in the standard form, we can extract the center and the radius from that equation. The x-coordinate of the center is going to be the value h, located here. The y-coordinate of the center is going to be the value k, that's located here. And the radius of the circle is going to be the value r that we get by taking the square root of whatever number it is that's on the far right of this equation. So in part A, we have an example of a circle that's written in the standard form. So we can get the ordered pair that is the center straight from the equation. Here we have x minus the x-coordinate of the center. Let's notice that the negative is part of the standard form. So this negative is not part of the x-coordinate. The x-coordinate is just the 1. So back down here, essentially we can think about this negative as having the meaning the opposite of. And then we could think about the x-coordinate of the center being essentially the opposite of what we see in here. So if we have a minus 1 in our standard form of the equation, the x-coordinate of the circle is going to be a positive 1. And here, since we have a plus 2 in the binomial, the y-coordinate of the center is going to be the opposite of that, or negative 2. We can also get the radius from the equation of the circle in the standard form, but let's recall that this quantity here is the radius squared. So if the radius squared is 16, that means the radius must have been 4. So to recap, we get the x-coordinate of the center by looking at the opposite of what's inside here. The y-coordinate comes from the opposite of what's inside here, and the radius comes from the square root of this number on the right. So now let's plot these values and graph the circle. So the center is at 1, negative 2. We'll plot our point as well as label it. And then there's a radius of 4, so that means we're going to go 4 units up from the center and land at the ordered pair 1, positive 2, 4 units down from the center, and then we'll land at the ordered pair 1, negative 6. We'll go 4 units to the right of the center, landing at the ordered pair 5, negative 2, and 4 units to the left of the center, landing at the ordered pair negative 3, negative 2. Now we do our best to connect those 4 exterior points with the circle, and this would be our answer to part A. Let's do the same thing here in part B. Again, we have the equation of the circle in the standard form, so that means we're going to be able to extract the center and the radius straight from the equation. The center is going to have an xy ordered pair where the x-coordinate comes from the opposite of what we see inside here. Well, when we have just x squared, that can be interpreted as x minus 0 quantity squared, so the x-coordinate of the center is just going to be 0. The y-coordinate of the center is going to be the opposite of what we see inside here, so positive 4. And the radius is going to be the square root of what we see on the right here. So our radius quantity is going to be 3. So now we graph the ordered pair 0, 4, and we want to always label our ordered pairs when we plot them. And then we will move up, down, left, and right 3 units to get 4 ordered pairs on the outside of the circle. So we'll go up to 3 units, which will give us another ordered pair at 0, 7, and then down to 3 units, which will give us another ordered pair on the circle 0, 1. And when we go right to 3 units, we'll get an ordered pair on the outside of the circle at 3, 4, and when we go 3 units to the left, we'll get another ordered pair, negative 3, positive 4. So then we connect the exterior points with the circle, and we've labeled 4 points on the outside of the circle. Notice that we can check the circle. Remember that any ordered pair on the outside of the circle has to be an ordered pair solution to the equation itself. So we could just pick one of these ordered pairs out here, and I'm actually going to select 0, 1 so that we have small positive numbers, and then plug that back into the original equation to make sure that it makes a true statement. So then the check would be to plug in 0, 1 for the x and y values in the original equation. So that means we'd plug 0 in for x, 1 in for y, and we'd get 0 plus 1 minus 4 is negative 3 quantity squared, and this is going to give us positive 9 is equal to positive 9, which tells us that this ordered pair is actually an ordered pair solution to the original equation, and therefore it's a point on the graph. Now, we could do that for all 4 of the ordered pairs around the outside, but we could not check the center point into the original equation. The center point is not an ordered pair solution to the original equation. Remember, the definition of a circle was the collection of ordered pairs that are a fixed distance away from the center, and that fixed distance is the radius. So this center point is not 3 units away from the center, it's not a point on the outside of the circle, and it would not be an ordered pair solution to the circle's equation if we were to plug it back in to check.